We are starting a brand new unit on statistics. So today we're just going to go over some very basic introductory stuff, probably things that most of you have seen before and probably already know some of it. Maybe towards the end there might be a little something that's new to you. We'll see. So let's get started on some definitions in statistics. We'll just go through one big old example. First example says a certain Instagrammer was thirsty for likes, so they posted 10 different images. The number of likes for the 10 images is shown below. So first picture got 28 likes, then 30, 35, 21, 19, 24, 22. Then they had one really nice post that got 58. Then the one after that, only 3. And the final one, 38. So the first thing we have to find is the mean. So the mean is going to be the average. So I'm going to show you kind of the formula you might see mathematically. This might scare you a little bit, and that's fine. But the formula mathematically for the mean is the sum of x of I, as I goes from 1 to n, divided by n. This is just going to be a really complicated way of saying add the first term, the second term, the third term, the fourth term, fifth, sixth, seventh, eighth, ninth, and in this case there will be 10. So this is like where you stop. We're gonna stop at the 10th value. So we're gonna add all of these up, 28, 30, 35, and so on, and that's gonna be hopefully 278. Don't check my math on that. But let's say it adds up to 278. To find the average, we have to divide it by the number of terms there were. And in this case, that is 10. So the average would be 27.8. So the average number of likes is 27.8. That's more likes than I'd probably ever get. The median. This is going to be the middle number of likes that a picture received if they were all lined up from smallest to biggest. So first thing we have to do is we have to line them up from smallest to biggest. So let's go ahead and do that. The smallest number was a 3, then there was a 19, 21, 22, 24, 28, 30, 35, there was a 38, and then that one really good post at the end, 58. So the first thing that we have to do is line them up smallest to biggest. And then we're going to start kind of crossing off pairs from the beginning and end. So the 3 and 58, those cross off. 19 and 38, cross off another pair, and another pair, and it leaves us with 2 numbers in the middle. So in this case, there were an even number of data points. We had 10 data points. So when you get to the middle, you're going to see 2 numbers. We have to find the number in the middle of those to become our median. So the number in the middle of 24 and 28, you can add them up, divide by 2. The median would be 26 for our median. So there is your median. It is just the middle number. If there's an odd number of data points, then you'll just have a number there for you. If there's an even number, add them up and divide by 2. Next thing we have to know is the range. And the range is just the highest value subtracted by the lowest value. So the highest value was 58. The lowest value was 3, which means the range is 55. So they had anywhere from 3 likes to 58 likes, and that has a range. It spans 55. So mean, median, range. You might also be thinking the mode. That's the one that happens the most often. In this case, they all happen once each, so there is no mode. So if something happens multiple times and it happens the most often, that's called the mode. Now we get to this thing called a box and whisker plot. Box and whisker plots are sometimes an easy way to display data, and 50% of the data will fall between the first and third quartile. That's going to be the box part of it. And then there's 25% on each of the whiskers. So you'll see why it's called a box and whisker plot. In order to do this, you need to know 5 different numbers. You need to know the minimum, the first quartile, the median, the third quartile, and the maximum. let's start by writing some of these out. The minimum we knew was 3. The maximum was 58. And the median we calculated earlier as 26. So now we get the first quartile and the third quartile. Those are the mystery numbers that we have to find. Let's take that same process we had for finding the median. So line them all up. So excuse me while I write these numbers out. 3, 19, 21, 22, 24, 28, 30, 35, 38, and 58. So what I'm going to do is I'm going to put kind of a line going right in the middle of this, which in this case was right in between the 24 and the 28. So that's going to be my middle. What the first quartile is it's the median of the left half, so the first half of numbers. So if I'm looking at this first half of numbers, we'll cross out the ends, and we get 21 in the middle. That's our first quartile, 21. And the third quartile will just be the median of the second half of numbers. So cross out the ends, and we get a 35 as our third quartile. So now, in order to create the box and whisker plot, we're going to start at 3 and go all the way up to 58. So we'll call that 3. We'll call that 58. And now we want to try and draw this as close to scale as possible. I know on these little sketches it's not perfect, but let's go ahead and put 26 right about there. We'll call that a 26. 21 would maybe be right about there. We'll call that 21. And 35 maybe about there. 35. And this is going to be our box. So here's your Q1, here's your Q3, here's your median, and those are kind of compromising the box. The whiskers are the parts out on the end. So we have this other definitional term, which we'll use in just a second, called the interquartile range. And that's basically the range of the box. So our box goes from 21 to 35, so the range of that is 35 minus 21 equals 14. So the formula for that is just Q3 minus Q1. Q, missed. We'll try that again. That looks like an A. Q1. So third quartile minus the first quartile, that gives you the interquartile range. And now the thing that might be kind of new to you is this thing called outliers. A value is going to be considered an outlier if it is more than 1.5 times the interquartile range above Q3, or 1.5 the IQR below the first quartile. That's a lot of words. Let's go ahead and look at the example. In this example, we knew that the interquartile range was 14. So if I have 1.5 times the interquartile range, we take 1.5 times 14, and that is 21. So there's going to be an outlier if it is more than 21 bigger than this, or if it's less than 21 smaller than this. So let's see the range of values that could be considered an outlier. If I take 21 and subtract 21, so if I take Q1 and subtract this 1.5 IQR, we get a value of 0. So anything below a 0 would be considered an outlier according to this set of data. Or we could have Q3 plus 1.5 times the interquartile range. Our Q3 was 35, then we can plus 21, and that's a 56. So anything that's 56 or bigger would be considered an outlier. So outliers would be smaller than 0 or greater than 56. So in this case, we did have one value here that was a 58, and that is bigger than 56. So in this example, that 58, that one picture that got tons of likes, that 58 would be considered an outlier. We didn't have any posts with a negative number of likes, so there were no outliers going to the left side. Outliers are, sometimes you end up throwing them out of data sets, sometimes you end up keeping them. That's a debate for much higher level statistics, but right now I'm just showing you how to calculate them. If you show up to class this week, I'm going to show you how to do all of this electronically. So in class this week, we're just going to make a calculator that can do all of this stuff for us using Google Docs. So you'll want to be there for class this week. Otherwise, you can just do everything by hand. That's fine too. So I will see you in class, and we will learn how to do this all on Google Sheets. So see you then. Bye, everyone.